Hi guys, this is Paul with TweakTown. We're back here at Storage Visions 2015. Right now I'm sitting down with Howard Marks. He is a longtime contributor at Network Computing, and he is also the chief scientist of Deep Storage, which is an analyst and consulting firm. One of the hottest topics in the data center right now today, and there's a ton of buzz generated around it, is hyperconvergence and the emergence of these hyperconverged systems. Can you give our viewers kind of a high-level explanation of the difference between a hyperconverged solution and a typical implementation?
Sure. In general, hyperconverged solutions combine the compute and storage into a single package. And while you might think, well, servers have had disk drives forever, the difference is that there's a software layer in a hyperconverged system that lets the storage across multiple nodes in the cluster act like it was one shared storage system. So instead of having a fiber channel SAN, I can have spinning disks and SSDs in the servers.
And it addresses it all as one large block of storage, and that is mainly geared for simplicity's sake, correct?
Yeah, the whole idea, well, there's two ideas behind hyperconvergence. The first is storage is expensive, and storage systems are expensive.
Absolutely.
And that's an absolute truth. You know, if you go to HDS or EMC or Dell or NetApp, storage systems have a substantially higher profit margin than servers. And so the idea is the servers have these disk bays already. We can use that for the storage. We can solve all the problems of having local storage with software. And that works. The problem is that it's not as simple as it sounds from both the cost and the operational side. So it's true, I bought these servers, and these servers have disk drives, disk bays, so I might as well put drives in them. The bays are free, and bays in a Symmetrix cost more than the drives you put into them.
Yes.
Because enterprise storage. And so you would think that hyperconvergence is always less expensive. The problem is the software layer has its own cost. So the most common hyperconverged platform today is VMware's vSAN. vSAN
a lot of buzz around vSAN. Right
vSAN has a list price of $2,495 per processor. Since we almost always use two-socket servers, that's roughly $5,000 per server for the software function. And that, depending on how many servers you have and what kind of external storage you compare it to, isn't necessarily less expensive than using an external storage system. Operationally, vSAN is modern storage, and modern storage systems are a lot easier to manage than old-fashioned storage systems.
Yeah, it's that simplicity.
Simplicity is the key. You know, easy to use is easy to say, but it's hard to implement.
Absolutely.
And so we are looking for simplicity. And vSAN is very simple to operate as storage. The problem becomes, I now have this one server and it runs 10 VMs and the storage. And in fact, I've got 8 of those servers because I built a cluster. The way VMware guys normally work, if they wanted to make changes to one of those servers, they would vMotion all the workloads off of it and then turn it off.
Yeah, they can power it down and do necessary hardware modifications.
However, if that server was also donating storage to the cluster, as soon as I turn it off, I have lower storage resiliency because I'm not replicating to that server anymore. I've got lower storage performance because it had some SSDs that I'm not using anymore. And in the case of vSAN, where the default is two-way replication, now I only have one copy of my current data.
And that's unacceptable from just about every single
I'm a steely-eyed storage guy. We believe in belt, suspenders, thumbtacks, and staples because the pants shall not fall.
Exactly.
And so if you use vSAN, I would recommend set that to failures to tolerate equals 2, which is three-way replication. And
but that also affects the TCO advantage there.
It raises the costs because now I'm getting as many disk drives as I put in there, only 1/3 of them are actual usable capacity.
Exactly.
Some vendors are talking about, well, we'll do deduplication to solve that problem. And while I'm a big fan of deduplication in all flash arrays or in hybrid arrays if it's done right. Deduplication's a compute-intensive process. And if I'm using the same processors to do the dedupe that I'm doing to run the VMs, that means I'm going to be able to run fewer VMs per server. And so whether that's valid from a cost is a detailed, complicated calculation.
Absolutely. So with these claims of this simplicity, there are some catches, some gotchas in there that you have to be careful of.
There are things you have to be careful about, and the vendors tend to compare their new hotness to Tommy Lee Jones' old POS. and so you'll see comparisons about our new hyperconverged system is infinitely easier to use than what EMC would have sold you 10 years ago. And that's true.
Yeah, it was 10 years ago.
But what EMC will sell you today is substantially easier to use than what EMC sold you 10 years ago. Ease of use has been a constant in the storage business kind of since EqualLogic entered the market and said, look, it's easy to use. And everybody said, oh my God, easy to use, sell me some of those. So you have to weigh that ease of use carefully. The best of today's storage systems are really very easy to use. And in the next version of vSphere, there's a feature called virtual volumes, or VVols.
Very popular. People are really looking forward to that.
I have several times compared VVols to Godot. You laugh, and I assume that most of the geeks watching aren't fully up on their theater of the absurd, but there's a play waiting for Godot, and Godot never comes. And VVols were talked about 4 years ago at VMworld. They're finally coming. And what VVols does is it changes the unit of storage management from the LUN and the data store to the individual virtual volume. So now the storage system sees and understands each VMDK. And that's great because it means we can do things like take snapshots or replicate on different schedules for different VMs without having to group those VMs and say this data store gets snapped once a day. And the truth is, even if you did that, they wouldn't be good snapshots. They wouldn't be application consistent.
Correct.
So
you can get a lot more granularity and control there.
You get a lot more granularity and control, and that granularity makes what you do better beyond even just the granularity. Because when you take a snapshot of an application like Oracle or SQL Server, the data on the disk is never consistent. And so you have to quiesce the application, force it to flush all of its buffers so that the data on the disk is consistent, and then take a snapshot.
Absolutely.
The timing on that quiescence is very tight. The Microsoft VSS spec says you have 15 seconds from when the application is quiesced to take the snapshot. If you had 10 VMs in one data store, you could never get them all quiesced within that 15-second period. Yeah. So when you take a snapshot, they're crash consistent. And crash consistent is a euphemism for as consistent as the data would be if the server just up and crashed, which means not consistent. Yeah. And if you bring SQL Server back up from a crash consistent snapshot, it could be 3 or 4 hours while it runs integrity checks and plays logs forward and makes the data good again, during which you can't access the data. Yep. So the quality of snapshots is really important, and VVols brings that. But VVols also means that I don't really have to talk to the storage system directly anymore. The vCenter server makes all of those requests, and again, makes things a lot simpler. So, operationally everything is getting simpler, but combining storage and compute in the same box adds complexity to the compute side. And we have to balance out what that total value proposition is.
Yes, and it's a complex field, and there's so many different aspects that just even small minor changes can have vast, tremendous impacts, especially when making purchasing decisions. There are so many variables that it's always important to turn to experienced analysts such as Howard Marks, and you can follow him at Deep Storage and also at Network Computing. Thanks, Howard. I appreciate your time.
Thanks, Paul.
Thanks.